There are some conditions that we need to consider in testing for proportion. First, it should be a binomial experiment. It means that when you conduct a survey, its outcome should also be only be binomial, or we say it's either yes or no, true or false, agree or disagree. For example, you conduct a survey whether people would agree or disagree to death penalty. That is a binomial experiment. Or you want to check the TV show ratings. It's a yes or no. I'm checking on it or not. I'm viewing it or not. That is a binomial experiment because there are only two possible outcomes. Second, the conditions, if you multiply n, the sample size, and the proportion, it should be greater than or equal to 5. And when you multiply n and q, remember q is 1 minus the proportion. It should be greater than or equal to 5. These are both satisfied with mu equal to n times p, and sigma is equal to the square root of n, p, and q. Now what's the formula? To solve for a z-test for proportions, this is considered when the sample size is large and we're dealing with proportion or percentage. The formula is p hat, that is the observed proportion, minus p sub 0, what is the established solution proportion, divided by the standard deviation. Remember, there's a formula for standard deviation, and we convert it this way. So that's going to be p hat, what is the observed proportion, minus p sub 0, what is the hypothesized proportion or what is being established or what is the population proportion, divided by the square root of the population proportion and q sub 0 all over n. Now, these are the steps in testing proportions. Step 1, parameter of interest. 2, hypothesis. 3, assumption. 4, level of significance and tails, and also the critical coefficients. 5, the z-statistic. 6, decision rule. And 7, the decision.